Hello everyone. Today I'm going to be teaching you guys the covalent bonds and hybridization. So what are covalent bonds? In covalent bonding, atoms want to achieve a noble gas configuration, means the octet rule. Rather than losing or gaining an electron, they achieve the octet rule by sharing the electron pairs. A shared electron pair is called a bonding pair. Now let's take an example of chlorine, which is a diatomic gas. As you can see, both chlorine has 7 valence electrons, and none of them want to give their electrons because they are both highly electronegative. So what's the solution? Instead of giving away the electron, they will gonna share the electron to become octet, means to achieve the noble gas configuration. And the pair of electrons in the middle is called single bonding pair, or also called a single bond. Now, single bonds are also abbreviated with a dash. So instead of plotting 2 dots in the middle, we can also put a dash, which means a pair of electrons is being shared. Now, covalent bonds are categorized into 2 types. First, polar covalent bonds, and second, non-polar covalent bonds. And to get the better understanding of polar and non-polar covalent bonds, we need to know what is electronegativity. So, electronegativity is how strongly an atom attracts or precisely pulls the electrons to itself in a bond, to which we say atom strength. Now, as you can see on the screen, the small atom on the right side is more electronegative than the atom on the left side, which is big in size, because the smaller the atom, the more electronegative it is, because it has the ability to attract to the nucleus. The greater the attraction between electrons and protons, the higher the electronegativity gonna be. So in conclusion, the more electronegative the atom is, it will attract more of the electrons towards itself. So let's start off with non-polar covalent bonds. Non-polar covalent bonds means no poles, and it deals with the even sharing of electrons. Now, as you can see an example of fluorine on the screen, each fluorine has an electronegativity of 4. And as I said, electronegativity is the strength of pulling the electrons towards itself. So by seeing the electronegativity, both the fluorines gonna pull the electrons. So if they're not gonna move anywhere, we're not gonna get any plus or minuses, means any side being more positive or being more negative. Now I want you to look at the electronegativity difference. It says it's in the range of 0.0 to 0.4. Now as we do the subtraction of one fluorine from another, we get 0. Means it is in the range of 0.0 to 0.4, which means this element is a non-polar covalent bond. Whereas on the other side, we got polar covalent bonds, which means uneven sharing of electrons, and a slight pole is created, which means one side is going to be more positive or negative than the other. As you can see the example on the screen, fluorine has the electronegativity of 4, whereas the oxygen has the electronegativity of 3.5. Now, having said that, fluorine is gonna attract more electrons towards itself than the oxygen. Means fluorine is gonna be more negative than the oxygen. Also, the electronegativity difference range is between 0.4 to 2. Now, when we subtract fluorine from oxygen, we get the difference of 0.5, which means it is the polar covalent bond. So in conclusion, the higher the electronegativity, it's gonna attract more of the electrons toward itself, making the element more negative. And that's the difference between a non-polar covalent bond and a covalent bond.